So we have a problem where we want to find the area of this shaded region. And at first this is a pretty challenging problem because you don't see any way of getting this triangle, the area of this triangle doesn't really pop out. And it's not like you have something like this, where you have a piece of the circle and then you also have a circular piece. Because then you could just subtract the radius, the area of the radius is and all that. But you don't have any of that here, so it makes it a little bit of a difficult problem. So try it out for a minute and I'm about to solve it now. So the first thing you can do is define what areas you're going to get. So one easy area is the whole entire thing, right? We'll call it a whole. That's going to be easy to get because all you have to do is take a fraction of the whole circle, which is pi r squared, and then do 150 degrees over 360, right? Because it's just a portion of the circle. Then we're going to have to figure out how to get this triangle. A triangle. That's going to be the tricky part, and we're going to do that now. So you need to cut this in half so we can get two right triangles. And because we have this whole angle here, we know that you could just divide by 2 and you'll get the angle right here. So we'll call this angle theta, and it's going to be equal to 75 degrees. It's half of 150. So now we have an angle and we have a side. We can get our base and our height of this triangle. So the cosine of our theta is going to be equal to our base. We'll call that our base over 7. So our base is going to be equal to, plugging in that 75 for cos of theta, it's going to be equal to 1.81. We have a 1.81 here. We can get this, we'll call it the height value. It's also over 7. Oh, excuse me. This is sine theta is equal to height over 7. So then solving with this, theta is 75 degrees. Height will be 6.76. Now the area of any right triangle is 1/2 base times height, okay? Because you're just taking you're basically taking a square and divided by 2. So to find a triangle, the area of this whole entire triangle, right? We have 2 of these, so we'd say 2 times the area of each of these 2 triangles. So that would be 1/2 base times height, right? And I'll plug in the base and the height, which would be 1/2, 1.81, 6.76. These 2's will cancel, and you'll just have this multiplication here. And there you go. You have the area of your triangle, your big triangle. And that area is 12.24. Okay, so now we want a whole, right? And a whole, remember, I'll write it in red so you guys know what we're... A whole is going to be this whole region, all the way around. Boom. That's what we're solving for. So we know this is a 150 degree. If we have an entire circle, 150 degrees, we're just going to take this chunk. So we take the 150 over 360, and then we multiply by the area of the circle. So 150 degrees over 360 degrees times a circle. A whole equals 150 degrees over 360 degrees times pi. The area of a circle is pi r squared. What's our radius? Well, our radius, you could see, if this was a whole entire circle, it would go, and our radius would be 7 right there. So go down, this would be 7 squared. And that's going to be equal to 64, roughly 64. And remember, the FE is always rounding, a lot of rounding and stuff. So then A shaded would simply be the whole entire area minus that triangle. 64 minus 12.24. And that's going to be equal to roughly 52. And that's your answer. And on the test, it's going to be a multiple choice test, and you may get a multiple choice that says something like 16 pi or something. I don't know. What's 16 pi close to 52? I'm not sure. Maybe closer to 17 pi. Yeah. You'll get it in terms of pi, and all you'd want to do to make sure this answer is correct is just go 16, 3.14, roughly equal to 52. And that's how you'd solve that problem. Because the reason they put it in pi is some people solve it a different way that results in pi, but you don't want to always depend on having the same form of answer. You just want to have the same number. So I hope that helps.